Hello, welcome in this hydrogen webinar series. My name is Lennart van den Burg, working at TNO, the Applied Research Institute. And in the coming 20 minutes I will talk about hydrogen and especially on water electrolysis and the roadmaps towards 1 gigawatt water electrolysis in 2030 or even in 2025. So let me first start explaining something about TNO. TNO is an applied research organization and we work on technical innovation, social innovation. And the unit where I work, the energy transition, we have one main purpose: reaching the climate agreement and reducing our CO2 emissions faster, smarter, and create a higher social acceptance. And that's why we work with around 1,000 colleagues in the energy domain. Besides the energy transition units, TNO have more units. And we're talking about hydrogen. And the interesting thing is hydrogen is present near all units in the industry, in the traffic and transport unit. And also on the circularity part. I will talk about a bit more later on. About the hydrogen program within TNO. Hydrogen will play a key role in the whole energy transition. And in this slide I will explain what are the main drivers, the reason why we should work on hydrogen. First of all, hydrogen, especially electrolysis, is a way that we can integrate vast amount of renewable electricity from solar, wind more effectively in our energy grid. So that's a really important role of electrolysis. The second is the seasonal storage. I mean, we need to find an alternative of current fossil fuels, and hydrogen can play a key role in seasonal storage of our energy, let's say. And the third and fourth one is we need to have alternatives for maritime, aviation sectors where up to now they're not really an alternative for the fossil fuels, and hydrogen or even synthetic kerosene can play a great alternative, and also for high temperature heating. And these are the main drivers in Europe. If you, for example, look at China, their motivation for example, like air quality is really important to reduce the emission and to get a cleaner air. That's really an important driver. So what are we doing within TNO? Within TNO we have 6 programs. We're working on over 50 different projects on hydrogen, and we've got more than 40 years experience in this field. So looking at this slide, here you see the hydrogen supply chain, you can say. We're looking at hydrogen production, mainly green, but also low carbon hydrogen. We're looking at storage of hydrogen underground in the surface, in salt caverns or empty gas fields. After that, we're looking at the infrastructure. Can we reuse existing infrastructure in the Netherlands? Because the Netherlands is one of the countries with the most highest gas infrastructure to all the housing and industry. And part of the infrastructure we definitely can reuse. And at the end, we're looking at the use of hydrogen in different applications, in the automotive, in the aviation. And really important is the system approach. We always need to look where is hydrogen the best solution compared to, for example, heat pumps, compared to direct electrification options. So hydrogen will play a key role, but we look at the different options available. Yeah, in this webinar I will specifically focus on the hydrogen production by electrolysis. So the other aspects, it's not included in this presentation. A bit about the history. As TNO, we already worked on 40 years on hydrogen. This is a paper from 45 years ago where we explained that hydrogen will get a major role in the energy transition. The difference between 45 years then and where we're standing now is then the driver was mainly on nuclear energy actually. And now the driver is, there are a couple of drivers. I mean, as I explained, carbon, CO2 reduction, the climate driver. The cheap electricity prices going down all the time, and we need the storage solutions. So now there are more drivers why hydrogen will stay instead of 40 years ago or even 10 years ago. So the hydrogen economy will grow definitely. And here you find a report where TNO worked on, where we advised, make actually a roadmap for the Dutch government from what is needed to make clean, green hydrogen available the coming years. Now we'll start first worldwide, what's happening on electrolysis, and then we'll go down to Europe, and Germany and the Netherlands. This picture shows what's now the current status of electrolysis worldwide. So the last 10 years, 100 megawatts of electrolysis is built, let's say, mainly in the field of for the use of mobility and in industry. So that's not really a lot. So actually, if you look at the 100 megawatts over, let's say, 230 projects, and if you look now, there are a lot of projects in the pipeline, and we'll discuss a bit later in this webinar on that, One project we're looking at the Netherlands is a dual project. That project alone is already 20 megawatts. So you see the project size and the amount of projects is increasing. But just looking from a different perspective, if we look from hydrogen, for example, compared to solar energy, the hydrogen, especially electrolysis, is like 10 or even 20 years behind where the solar is standing now. So we really need to let grow the market and further develop the technology. If you see here, that's a projection up to 2030 if we want to reach 100 gigawatt scale in 2030 worldwide as a capacity. If you take the same graph and you put it about investment on the renewables for solar, wind and water power, you see that the investment on electrolysis is still minor, but it's actually really growing. But we are, we're just now in the front stage of the development on electrolysis. What are the main drivers for green hydrogen? This is a really important map where you see from what are potential leading countries where electrolysis can be competitive towards the alternatives. And the main drivers is, for example, wind and solar power. And they looked at from the amount of solar during the year, the amount of wind during the year. I also include the Netherlands and Germany here. And this is not an extensive list, just a number of countries are given. But if you look at the Netherlands and Germany, we're now building the largest wind park in the North Sea. And we've got a capacity in the complete North Sea over 150 gigawatt. So we've got a huge potential of renewable energy, for example, in the North Sea. And that's why we need hydrogen to make the wind energy, to convert it to hydrogen and to bring it into our energy system. The next thing is the role of ports in this whole picture is really important. So because in the future hydrogen will be an international market and hydrogen will be transported from one country to the other country, and the role of ports, of harbors are really important to bring the hydrogen further, for example, into Europe. Beside the technical drivers about renewable potential, there's also a lot of market drivers, infrastructure, which determine which country, of which area, of which continent even, will be, let's say, the first movers on the hydrogen part. And this graph says something about the potential. Different scenarios are given. And if we take the mid scenario, they're saying that in 2050, the potential capacity of electrolysis will be somewhere between 4,000 or 6,000 gigawatt in 2050. And imagine that I was just saying in the beginning, up to now, 100 megawatts installed. So the coming 30 years, you've got a great opportunity, a great challenge to work on. What's Europe doing now in the field of electrolysis? Hydrogen is now a key element in the European strategy and the European Green Deal. This summer, the Clean Hydrogen Alliance will become more concrete, and Netherlands and Germany is really leading this initiative. And I think it's great importance that industry, government, the transport operating companies working together, because it's not about production, it's about infrastructure, it's about storage, it's about the whole supply chain. And it's important that there is also from a government side, a scheme needs to be there to actually stimulate this development in that way that it's not too much pushing hydrogen, but make clean hydrogen available also compared to the alternatives. And one of the nice examples is an initiative for Hydrogen Europe to go to 2 times 40 gigawatt in 2030. One important thing is cross-border cooperation. These are 2 nice projects where TNO is working on. One is with Germany, where we're actually looking from can we use current gas infrastructure, can we use the storage capacity, can we connect the wind energy both in the Netherlands and Germany, produce hydrogen and transport it around Germany and to the Netherlands to the different industrial clusters. And this kind of cooperation between Netherlands and Germany and also between other countries is really important, because one country can't do this alone. So that's a really important one. And the second one I want to talk about is about the hydrogen project, where we identified a lot of different technologies, energy carriers, hydrogen, but also energy carrier like ammonia, and how the future hydrogen market will look like, and what are the potential future new demands, what are the future costs, and how this market can be developed. And we identified 8-9 countries where hydrogen production can take place, and now bilateral discussions are going from, can we maybe import hydrogen from, for example, Morocco towards the Netherlands? So a lot of initiatives are coming from there as well. Where are we standing now? Up to now, there are a lot of pre-feasibility studies, engineering studies, and first large-scale pilots. I just give here a couple. For example, we work on the North HU project, where the ambition is to go to 2-3 gigawatts before 2030. And it's a pre-feasibility study to see what's needed to actually make this possible. One of the challenges we see there, for example, is the supply chain. If you look at the electrolyzer stack, there are maybe now 2 or 3 parties delivering the membrane for the electrolyzer stack. So the complete supply chain is not developed yet. So in order to build really large gigawatt systems, we need the whole supply chain of the stack manufacturers, the components developed, and even the material supplies. The whole supply chain need to be developed, and that's one of the things we look from what's needed to actually make the 2-3 gigawatts possible within this decade. And all the other studies are looking at that as well. And the interesting thing is they're all connected to wind turbine, which is needed because it only makes sense to making green hydrogen connected to wind or solar, but also to look at alternative demands, for example, looking at aviation fuels or looking at the maritime sector. So these are feasibility studies. Also pilots are now on the way in the north of the Netherlands. A 20 megawatt initiative is signed this year. And in Austria already a 6 megawatt system is, electrolyzer system is running connected to a steel plant producing green hydrogen there. Designing a gigawatt electrolyzer plant is not that easy. I mean, up to now, there are projects done on a megawatt scale and there are containerized solutions. If we want to build a gigawatt electrolyzer plant, we need a complete redesign of the plant itself, let's say. And this is a sketch for how such a design can look like. We've got here this design for an alkaline system. We've got here the different stacks standing. We've got a separate unit for the water demineralization. We've got a central compression. We've got obviously high voltage connection. And an optimal design is really crucial to get to the cost reduction, because a lot of the costs are actually in the electrolyzer stack, but a lot of it is also in the whole electrolyzer system and also the power connections. So an intelligent design is really important, and there's a lot of variations. Mainly thinking about maintenance, thinking about lifetime of these systems. That's where we're working on continuously. What's happening now in the Netherlands? I started with the international, I went to Europe, and now going into the Netherlands. Over 25 large projects are announced, and the projects differ. I mean, there are projects on the North Sea where we're building electrolyzer on an existing platform to see from how does an electrolyzer behave in sea conditions. We're looking at hydrogen storage from how does it work if we store hydrogen underground in an empty salt cavern? How can we learn from it, and what are the opportunities there? And obviously a lot of hydrogen projects connected to the large industry which are in the Netherlands. For example, connected to the steel industry, connecting to refineries, where green hydrogen is a good way to reduce the CO2 emissions. And this is not an extensive list, this is a complete list of all the projects which are being developed up to now. Important to say, I mean, there are a whole list of projects, but not many final decisions are made yet. So the coming years will be quite exciting to see how this will further develop. Now let's further look into the market. Looking to the market from the Netherlands and Germany. What do we expect that amount of hydrogen will we use in the future? Here you see four different scenarios, actually, of three actually. One is the current demand in the Netherlands, our energy mix, and three demands in 2050, looking at the local, looking at the national, and looking at the international scenario. This is for the Netherlands. And you see that in this energy infrastructure outlook from the gas grid operator together with the transmission grid operator, they see hydrogen will get around 24% to up to 38% in our total energy mix. Electricity is obviously much more, 39%. But if we look at and the same for Germany, the numbers are a bit lower. But if we look from what will be the installed capacity in Netherlands or in Germany with electrolysis, and in red you see here the installed capacity, and there you see a big difference. I mean, in a local or national scenario where we really investing in the Netherlands and Germany in local renewable energy, so we're investing a lot of in wind, a lot of in solar, then there's definitely a need for hydrogen, because we need to convert some of that electricity into hydrogen and store it and transport it. I mean, in an international scenario, our local production will be much lower, and we will import a lot of that hydrogen. So the installed capacity in the Netherlands and even in Germany is much lower. And current policy will really are a combination of local and national. And import will get a role, but not as big as in this scenario is given. That's the current policy outline. How much hydrogen are we using now today in the Netherlands? Netherlands is, together with Germany, the largest hydrogen user and producer in Europe. And here you see some graphs from 2017 to 2019 where hydrogen is used in different industrial clusters. And important to say, this hydrogen are now used for example, for refinery or for fertilizer production. I mean, if you're looking 20 years further, you can question whether this industry will still exist and will stay in the Netherlands. But if we look at one other scenario, I just gave the scenario from an infrastructure perspective. As TNO, we worked on two scenarios on how our energy system will look like in 2050. And these are complete other numbers. Here we see the different sectors: built environment, industry, transport, and see the hydrogen will be mainly used in the transport and in industry. And in the adapt scenario, we will do we're not making major changes. And in the transform scenario, we're really changing our behavior and the way industry is now organized and the type of industry we have. And if we look now at the numbers, then hydrogen is 25.7 petajoules in both, about 50 gigawatts installed capacity in the Netherlands, much lower. And the difference between those scenarios, also interesting to see, is in this scenario, it's mainly low carbon hydrogen, so mainly using gas, SMR, ATR, and steam methane reforming, and capture the CO2 and store it on the ground in this scenario. And in this scenario, we're mainly working producing hydrogen based on electrolysis. So there's definitely a competition between those both. I mean, they can facilitate each other, but in this scenario, it's one or the other. But important to say, I mean, these are scenarios. I mean, we analyzed in the Netherlands more than 20 different scenarios. And on 2019, you see here the baseline demand based on the current industry. And there's a quite big range that the hydrogen demand in the Netherlands coming 30 years will or stay the same, or will be like 5 or maybe factor 10 larger. And the difference is really what will the transportation will do, what was the role of the industry. So main message I want to say here, I mean, hydrogen will play a key role, definitely electrolysis, because otherwise we can't integrate all the renewables into our energy system in the Netherlands and Europe or even worldwide. But the role of hydrogen in our complete energy system really is depending. Will be 5%, will be 20%, or even 30%. I'm already coming to the closure of this webinar. We organize a next webinar, and then we talk more about, we really go into that electrolyzer, and we talk about next generation electrolyzers. And this picture shows this is current generation electrolyzer where we're looking at now, and that's where we want to go towards gigawatt scale. But as TNO, we also develop the next generation electrolyzer, and what are the main challenges? And yeah, when will that next generation electrolyzer will be ready? Yeah, if you're interested, please join our next webinar. Thank you very much.